Hello, and thank you for joining our latest Finovate webinar. I'm David Penn, Research Analyst with the Finovate Group. Our topic for today, the underpinnings of bad bots and their impacts on financial services customers. A regularly refreshed library of stolen user credentials, attack management toolkits, and a delivery infrastructure that masks identity and location allows bad actors to launch large-scale automated attack campaigns against your public-facing applications. By targeting the application APIs directly, as opposed to the web forms, attacks such as account takeovers and fake account creation can remain undetected by existing security solutions, quietly leading to fraud and reputational damage to the target organizations. In this webinar, we'll highlight common automated attacks targeting financial services, mobile application security risks that are hiding in plain sight, what a bulletproof proxy is and why it matters, and how bulletproof proxies came to be and their place in the cyber community. Our speakers for today are Matt Kyle, Director of Product Marketing at Sequence, and Alyssa Knight, Senior Analyst with ITE Group. One more thing before we begin, this is an interactive presentation, so we look forward to fielding your questions. Please use the Ask a Question button at the bottom of the screen to send us your questions, and we'll reserve some time at the end of the presentation to respond to them. So with that, let's go ahead and get started. Matt, Alyssa, take it away.
Thanks very much, David, and thanks everyone for attending today's webinar. Let's get started. Let's talk a little bit about Sequence Security, and I'll talk a little bit about who I am. Joined Sequence just a few months back after a long-term stint at Palo Alto Networks, and prior to that, Juniper Networks and NetScreen. So a long history of security behind the scenes. Sequence Security is an application security customer. We're venture-backed, located here in Sunnyvale, addressing the automated attacks or bots that are targeting financial services, as well as application vulnerability exploits. Alyssa, I want you to talk a little bit about who you are and what you bring to the table.
Sure, Matt. Thank you very much. So I'm the resident hacker here on this webinar. I like to say I'm a recovering hacker of 20 years. No, I do not wear trench coats or rollerblades or hoodies. Not all hackers wear hoodies. I am a penetration tester. I've been a pen tester for about 20 years, like I said, more recently living in Stuttgart, Germany, focusing on hacking connected cars and working with some of the largest automakers in securing their cars, which communicate with APIs. I've spoken at over 3 dozen security conferences across the U.S., Middle East, Europe, and Asia. So I am on the road a lot, speaking at conferences about my research, my most recent vulnerability research. I did actually publish the first vulnerability on hacking VPNs in 2000 under the hacker alias Loki. So I've spoken at Black Hat briefings and numerous other conferences in the past on previous vulnerability research that I've published. The more recent vulnerability research that I've been involved in was actually downloading 30 financial services mobile apps, and we'll be talking about that today, but actually went on the road as a result of those findings to talk about all of the findings in those apps, all the vulnerabilities that I discovered in those apps, and the most prevalent vulnerabilities we'll talk about in this presentation today. So I would say that my focus in my research today in vulnerability research really is around hacking APIs and containers, and I am a published author, so I've published a new book on hacking connected cars, and I just got a new book contract, Matt, where with Wiley, where I'll be publishing a new series of books on hacking APIs and securing them as well as containers. So all fun stuff.
Awesome. Thanks very much. All right. So when we talk about financial services organizations and their public-facing applications, let's make sure that everybody understands what that means. You know, it's not most of the financial service organizations, and many organizations, even retail, hospitality, so on, have built rich public-facing application infrastructures where you log in and you access items of value, assets of value. Financial services, I'm logging into my investment accounts, I'm managing my money, I'm paying my bills, I'm researching future investments, I'm planning my retirement, and I'm doing that from a mobile app, I'm doing that from a browser-based app. Oftentimes there are different form factors to improve performance and improve the user experience. And many times they might be accessing, using APIs to call different components on the back end. They might be calling the databases, they might be calling a content repository to populate the web page, research repositories. And these APIs are being accessed sometimes directly from the mobile app or indirectly through a web form that calls the API. So this is an important piece of the conversation today. The use of APIs in terms of application development is increased dramatically over the last few years, being driven by a number of different things. It's being driven by the rich user experience that I just described. It's being driven by the need to integrate more appropriately, or more tightly, I should say, with other back-end applications, other partners. It's being driven by the drive towards modular applications, moving away from monolithic applications, allowing application components to talk to each other. Typically, those are done through APIs. Here's some research that I found just yesterday from a company called SmartBear. They're an API management company. It talks a little bit about some of the drivers some of the things that are driving the increased use of APIs. On the upper left-hand side, you see that it's web and mobile are the primary targets for API development. The reasons why is that chart on the right. I already touched on a few of those. And then are the APIs external, internal, or both? That's the lower left-hand corner. And as you might imagine, most organizations are doing both types of API development. In the financial services industry, it really does rely heavily on APIs. The OFX API is the universal standard for funds transfer, moving money around, and as you might imagine, it's well documented and it's targeted by attackers, and I'll talk about that in a moment. And then, not to dwell on the mobile aspects too much, but mobile applications do use APIs very heavily, and one of the things that is very important to remember and always focus on is APIs are stateless. So they will send, typically, if you're using the API, you're going to send the entire request for information and then you're going to get the answer back. Whereas an HTML interaction, a form, you might be doing some back and forth interaction through that form. So APIs are stateless, and attackers can absolutely target those APIs directly. The final statistic to kind of consider and really does open your eyes is Akamai took a look at the web traffic, and 83% of the web traffic these days now is API-based. Up from, I think it was 40% back a couple of years ago when they did the last assessment. The primary driver of that API traffic are devices, smartphones. Again, hammering home the point of the use of APIs and the stateless nature of APIs. So, here's the challenge, right? All of these public-facing applications, particularly financial services, are attack targets. We're going to talk about the components in the orange box there on the left-hand side today, but attackers will use these four elements: user credentials that have been stolen and constantly refreshed, attack toolkits, and compromised infrastructure to launch automated attacks against web, mobile, and API-based applications in the financial services industry. They are difficult to stop because they appear to be legitimate traffic, right? Think about a credential stuffing or an account takeover attack. That is the process by which an attacker is automating the repetitive login attempts using stolen credentials. So it looks like, to the financial services customer, it looks like a legitimate login attempt that's failed. So they trying to weed out those malicious attacks becomes an ongoing cat and mouse challenge with the attackers. Now, I'm going to switch gears a little bit and have Alyssa chat a little bit more in depth about some of the API research she's done, and then I'll come back online and we'll continue the conversation around the attack components. So, Alyssa?
Cool, Matt. Thanks for handing me the baton. So as I mentioned earlier, I just completed research into 30 financial services mobile apps, which included banks, stock brokerages, insurance companies, P2P payment applications. And the process for my research really was simple. Just downloading the Android app, using a tool, coincidentally enough, downloaded from the Google Play Store that allows me to export an APK package off of an Android device to the cloud, where I can then download it to my workstation and analyze it. So I exported the APK, then I decompiled it with a free tool called MobSF. And so that's really a drag and drop system, which is great, saves a lot of time, allowed me to just literally drag and drop the Android app package, the APK file onto my web browser, and which then ended up in the uploads folder of MobSF. And believe it or not, I actually just used command line tools from that point on. I didn't use the GUI. I just used a combination of grep and awk within that folder looking for keywords. And so, the interesting thing here is a lot of people think that, hackers walk into things like this already knowing everything about a subject matter before doing it. And that couldn't be further from the truth. As a matter of fact, I walked into this not really knowing anything about APIs, and learned about APIs in the process of doing the vulnerability research. So what I did was I needed to figure out what it was I was looking for, because I really didn't know what I didn't know. And I just went to the FIs, to their website, and actually pulled their API documentation to understand what does the needle in the haystack look like that I'm looking for. That's really how simple the process was. Here's a great slide about the open source intelligence process, the OSINT process I went through. And the funny thing about this slide, the reason why I have that emoticon there is, if you can see that warning banner right there on Amazon's website, it literally says, do not do this. Do not hard code this information in your source code. And I have an actual screenshot of source code right below that, where you can tell that literally they copied and pasted that and just ignored the warning. So my findings out of the 29 out of the 30 apps was, it was pretty endemic, the amount of hard-coded APIs, hard-coded secrets, tokens, credentials, S3 bucket credentials and keys. Just the amount of things that I was finding was astronomical. And the findings were so bad, I actually stopped using 2 of the services that I included in the research. So this is a great example of, again, going out there and researching the API documentation that's freely available to the public to read, and then going in there and using grep to find in the source code those particular, that signal and the noise. Next, this is just, again, more OSINT in action, where I went to a third-party payment processor, and I really didn't know what I was looking for with this. And you can see that they gave me the keywords here to search for. With the screenshot here, you can see the person who's writing an app for this service needs to specify the environment, the public key, the private key, and the merchant ID. And then here you can see a lot of that being hard-coded in the code. So, this is a great example of, really, I didn't know what I was looking for. All I really needed to do was go to the website and figure that out, and then go back into my code and find it. You can see there's API keys here. You can see there's all sorts of variables that, because the companies didn't obfuscate that source code, I was able to reverse engineer it and then easily go through the code and scrape it looking for this information. Here's another great screenshot of my findings. Here you can see clearly that you've got some API URLs here. You've got some branch information. You've got claims information. So clearly this was an insurance company. But these are all targets. All of these API keys along with those API URLs, that tells me exactly the URLs that I need to target in order to copy and paste these API keys and send them and attempt to communicate with. So again, a really great example of the kind of sensitive crown jewels that can be found in source code. A list of the total findings are documented here. I found AWS credentials, secret keys, access keys, session tokens. I actually found private certificates, private keys that were hard-coded in the code. There was a directory on one particular financial institution. They actually named it Combined Public and Private Keys. And I was actually able to import some of the private keys into my keychain, which had no password on them. So there wasn't even, security through obscurity there. They literally named it all private keys for hackers to go in there and find all those keys if they wanted to. Hard-coded tokens, access tokens used for authentication, that sort of thing. So, just devastating findings, including Salesforce credentials. I found hard-coded Salesforce credentials and S3 bucket credentials and keys. So I'll hand it back to you, Matt.
Now, thank you, Alyssa. A quick question for you, Alyssa. So when we talk about an automated attack, like a credential stuffing or an account takeover, these are all the things that you just talked about are the elements that a hacker, a real hacker, as opposed to a white hat hacker, would use to deconstruct the app and then begin to use those elements to launch an automated attack. Would that be your assessment?
Yes, correct. So, if a black hat were targeting these financial institutions, they could easily get all the API information from these FIs simply just by downloading their app, reverse engineering it like I did, decompiling it, finding all the goodies like the target URLs and the keys and the code, and then proceed to go after the FI from there.
Cool. Great. So now this slide that we're showing here is what I would call probably the most common attack against financial services. There are many, many different types of automated attacks. Content scraping, denial of inventory, application DDoS. But the most common attack that we see, the initial attack anyways, is an account takeover. It's where you take the stolen credentials found on the web and constantly refreshed. Every week it seems that we have a new trove of stolen credentials that are constantly being stolen and then refreshed on the dark web that attackers can use. They will use those credentials to launch the automated attack targeting the web form. They might be targeting the mobile or the APIs, as you see here. And really the goal is, it could be multiple goals. They could, if they validate the credentials, those credentials then become higher in value on the dark web. So there is a very robust market for validated user credentials. In other cases, they're going to go to the next step. They're going to steal your money, commit fraud. Things like loyalty points fraud outside of financial services are very common. Gift card fraud, gift card theft, automated shopping. These are all the different types of attacks, secondary attacks that a bad actor is going to execute depending on the industry. If you drill down a little bit further into what some of the things that we're finding is that attackers are targeting mobile applications, possibly because of all the poor coding practices that Alyssa just talked about, much more so than they are web. I'm going to drill into some of this research that we uncovered and published about a month ago. But when we looked at the attacks that are hitting our financial services and retail customers, we found that 70% of the attacks were targeting mobile endpoints as opposed to web endpoints. Most of our customers have far greater number of web endpoints than they do mobile, which means that there is a dedicated focus, if you will, for the attackers to be targeting the mobile endpoints. And pulling a statistic out of Alyssa's research, and something that she just talked about, 27% of the applications that she analyzed had hard-coded the API keys, giving them easier access making it easier for them to launch those attacks. And we already talked about the Akamai statistic that you see listed there at the bottom. Now, here's a real-life customer example. So I went back and did some research into our customer database, and this particular attack on a financial services customer targeted the mobile login API. So they went direct to the API. They had done the analysis of the mobile application, found the API that required login, and rather than going through, automating it through the mobile app itself, they targeted the API directly, launched an account takeover. When they were able to find a valid user, so they got confirmation, yes, welcome to acmefinserv.org or .com. Immediately they initiated the second phase of the attack over the OFX financial services protocol that allowed them to transfer funds. So in this particular case, they were stealing my money when they got the validated user credential. So this is a perfect example, a real-life example of how a financial services customer was faced with from an automated attack perspective. All right, so let's switch gears a little bit and talk a little bit about the different components. So, stolen credentials. This is a pretty obvious one, right? Every week we see these new breaches. I think today I saw across the newswire that many of the Hurricane Sandy victims in the FEMA database were exposed because of a poorly configured database. So just another example, a few weeks ago we saw Capital One come under fire because of an exposure. I think we've almost become numb to the release of private information because it is so frequent. Those credentials can then be launched into attack toolkits. As I described earlier, I've been in the security industry for a fair number of years, and in my early days at Palo Alto Networks, we used to find hackers. You'd have to go to the dark web or nowhere to go to find toolkits and find access to proxies. Nowadays, the attack infrastructure, the attack toolkits have really become commercialized. The command line and writing scripts has given way to point-and-click tools. You can buy copies of Century MBA or Sniper. These are common attack toolkits for $20 on the dark web, and then use those tools to launch an attack. So it's become very commercialized and easier to launch these attacks. The criminal infrastructure is an important piece of that because the criminal infrastructure allows you to anonymize yourself. Here too, in the earlier years ago, not too many years ago, you'd have to kind of sniff around to find access to this type of an infrastructure component, right? things that these tools are billed as tools that allow you to mask your identity, and they do have a positive use, right? So, maintaining anonymity allows whistleblowers to bring to light certain problems within an organization or a government. It allows suppressed individuals to communicate outwards. So there are absolutely positive use cases for tools that anonymize an individual. But when you look at this type of a tool, what we are calling a bulletproof proxy, where the vendor is marketing that they have 10 million IP addresses that allow you to mask your identity, this brings it to another level of scale. And it also highlights how out in the open these vendors have become. So this is the screenshot of this particular vendor. It's smartproxy.com, I think it is. You can go there and you can sign up and begin to anonymize your identity and your location. Now, one of the things that they have is that you can, if you want to launch an attack towards a particular region or country, you would go into the user interface, select the country or location, and all of your traffic will be routed through that gateway. What this does is it makes it look like your attack is local. So again, this financial services customers that we have are global in nature. They're going to, what the attackers do is they will do very region-specific campaigns, or they'll distribute the attack globally, depending on their end goal. So you can select the gateway to mask your location, and the distributed nature of the residential IP addresses really does help ensure an anonymity. What we did is we subscribed to this service and we began, sending messages across the different locations. So what we were able to do is we were able to analyze almost 1 million IP addresses, and the image on the left-hand side for this particular vendor shows the global distribution of by country of the IP addresses, and then in the right-hand corner we did a little bit more granular analysis to show the different organizations and that these IP addresses are coming from or coming through. Now, when we talk about residential IP addresses or residential proxies, let's make sure that everybody's on the same page. What this means is that these are Comcast routers, these are cable provider routers, they are my refrigerator, they are smart home devices, they could be your own wireless router, it could be your garage door opener, anything that is now connected to the web that might have poor administrative password practices, or might be known to be compromised. All of these devices can now be used as proxies, if you will, to route the traffic through towards the attack target. And what that does is that makes the IP address look like it's coming from the United States and it's coming from a Comcast. So it means that the attack target, the financial services customer, is going to be less likely to block that attack. Whereas if the IP address is from Russia and it's on a known blacklist, that particular IP address is going to be much more likely to be and much easier to be blocked. All right. So the other thing that the Smart Proxy does is it integrates very nicely with your browsers and HTTP libraries. So it becomes very user friendly to distribute an attack across a large number of IP addresses from a location of your choice to maintain anonymity. Finally, you would select the different bots. They have predefined bots that you can use. Some of them are, seemingly legitimate. Sneaker bots are a scourge of the retail organizations, but they are, to a certain extent, allowed. And then further down, you'll see an AIO bot, which is an all-in-one bot. So you can have prepackaged bots, or you can create your own and launch your own. Now, the final pillar, if you will, of an attack character of the attack infrastructure components is behavior. If an attacker is dedicated, they are going to modify their behavior based on the resistance that they may or may not encounter. We had a customer outside of the financial services organization. They are a social media company, and one of the things that was very interesting to observe in that environment is what we call keyboard smashing. So the attackers would use just random keystrokes, kind of like when you smash your fingers on the keyboard, to generate a unique email to log in. And when the email and user ID was rejected, they would then get access to a new web page, and they would use automation to continue to create a fake account. So they used a combination of human interaction and automated interaction to create a fake account. And then they went on to the next phase of the attack, which was to spread disinformation about users in the in this particular social media customer base. So behavior is just an ongoing cat and mouse game. If an attack, we have customers that have been using our product for more than 3 years, and we see the same attackers targeting those customers, just continually modifying their behavior, looking for new vectors, new ways to take advantage of the financial services application. What I'm going to bring Alyssa back in. We've talked about a number of things. I want Alyssa to talk about, what should a developer do, given what we're showing and talk about today, relative to creating your mobile apps. Alyssa?
Sure, thank you, Matt. Yeah, I mean, one thing I want to add on here that isn't here is when you have a hammer, everything looks like a nail, right? So one of the things that I find is companies need to understand that there definitely is a difference between API management gateways and API security gateways. And even though the current analyst community really doesn't want to recognize that, I am a big proponent of decoupling those things. I really want organizations to start seeing and understanding that they need to secure their APIs with solutions that are purpose-built from the ground up to be API security solutions. That security should not be a feature of an API management solution. Security should never be a feature of anything. Security should be built from the ground up, purpose-built from the ground up with that in mind. So having said that, one thing that I would recommend is definitely organizations should be securing their APIs with an API security gateway, and not relying on their management solutions to do that. They need to understand that things like code obfuscation need to be done on their API on their mobile apps. So it makes it more difficult, not impossible, but difficult for organizations for hackers to go in there and decompile the code and find the kind of things that I found, like API keys. The other thing I would recommend is, maintain, is first of all, understand that base64 encoding is not encryption. One of the things that I did find was there was a lot of sensitive information in a lot of these apps that were base64 encoded. Instead, and what maybe the developers didn't realize is you can actually take base64 encoded text and go to a free website like base64decode.net and actually decode it. Encoding is not encryption, and that's definitely what I would want to impress on everyone as well. And that, the organizations have an API security policy. They need to treat their APIs, their API servers, their modes, all those things, the same way they would treat the security of their servers. Make sure that the APIs, that the servers are all part of a regular patch and vulnerability management program, as well as the mobile apps, and that static and dynamic code analysis is being done of the APIs, and that the traffic is being interdicted, that the API traffic is being inspected, it's being interdicted by something, and analyzed and made sure that, that you're not trying to secure APIs with a WAF. I understand that APIs speak HTTP, the HTTP protocol, but people need to understand that, you can't secure APIs with a WAF. It's why a lot of APIs are getting breached today. People are trying to secure APIs the same way they would secure a website. The other thing is, remove or tokenized sensitive data in URIs. One of the biggest findings, and I know I didn't talk about this here, is that, there were definitely some apps that I looked at where sensitive information was being passed in the URI. And what people need to understand is that when you pass sensitive information in a URI, it shows up in the refer log. And when you go to a website, for example, refer log tells you basically where you came from, what the URI was of where you came from. And if it's got if it's got sensitive information in the URI like a key, it's going to show up in the referrer logs for the new server. So definitely tokenize sensitive data in URIs. And again, continuously review, continuously monitor, and continuously improve your security program and making sure that your APIs are a part of that. So I'll be talking more about my vulnerability research around this at future Finovate events. I'll be speaking at Finovate Fall and Finovate Singapore for Finovate Asia. So definitely please come talk to me at those events. If you have any questions about my research or would like to know more, that would be a great venue to do that. So with that, I will give the microphone back to you, Matt.
Thanks very much, Alyssa. So, one of the things that, that we always need to keep in mind is oftentimes the application developers are working outside of the security teams. We need to bring those teams together and, to really focus on application security. One of the things that we've seen with our customer base is that, the web, mobile, and API-based applications, the public-facing applications are updated fairly frequently. New features, new versions get pushed out, and if the security team is not aware of it, sometimes those applications can be missed. Understand the other thing to do is really do understand the adversary and the attacks. Figure out who's attacking your site, what their goals are. Really do understand who the adversary is and what they're after. Enlist folks like Alyssa to give you some commentary on what we're seeing outside of it. Talk to your peers. Really do focus on the attackers. They are increasingly sophisticated. They're patient. We have attacks that we see executing low and slow attack patterns where it's just a few requests distributed across individual unique IP addresses on a weekly basis. So that script is just running and the attacker is off working on something else. our approach to protecting public-facing applications, including those that use APIs, is a little bit different than some of the existing approaches. We use an intelligence-based approach, AI and machine learning and other detection mechanisms that are analyzing a copy of your public-facing traffic, all of the public-facing application traffic, to first discover all of the different URIs and pathways, and then look at the transactions and requests themselves to look for patterns, speed of the speed of the login attempt, the location, all different types of patterns that might indicate malicious versus legitimate. And then we give you the option of blocking it, sending a deceptive response back, rate limiting, geofencing, or sending the information off to an existing component of your security infrastructure to respond or analyze further. So all of the findings can be exported. And then the last thing that's very important to understand is that we take a software-only approach. We are 100% software, container-based software actually, and so it can be deployed in your data center, in AWS, Google Cloud, Azure, and we have a SaaS offering coming out shortly. So a variety of different deployment options to fit your application infrastructure. So that's a little bit about how we approach API security and public-facing application security. I see, David, you want to fire away at the questions that are coming in on the question chat?
Certainly. Let's go, definitely go ahead and move to the Q&A. I want to thank both Alyssa and Matt for a very wide-ranging and really in-depth conversation on a number of these issues with regard to API security. Also want to remind those of us listening that we are taking questions, so go ahead if you have a question for us. I know some of the material might seem quite extensive, so don't be afraid if your question might seem more fundamental. I'm sure both Matt and Alyssa would be happy to address questions all across the scale. And again, just go ahead and use that Ask a Question button, and we'll get your question into the queue, and we'll get Matt and Alyssa to respond to it as soon as it comes in. Let's go ahead and take a look at some of the ones that we do already have in the queue while those of you are getting your questions in. Let's start with this first one here. How do you protect API-based apps is the question. And that's probably for both of you. Go ahead.
Yep. Sure. I kind of touched on that a little bit, but we take the best way to talk about it is how others might try to protect API-based apps. So, we consider ourselves to be a second generation bot mitigation offering. So we take the intelligence-based approach. We take a copy of your public-facing traffic off of your load balancer or your switch, and we send it to our analysis engine. The analysis engine, as I mentioned, would go through and look at all of the requests using machine learning and AI and other detection mechanisms to separate legitimate from malicious requests. The malicious requests can then be as I mentioned, blocked, alerted on, rate limited, deceive, deception, or geofencing, or you can send it to your existing security infrastructure. The first generation bot mitigation folks took the approach of injecting JavaScript into a web page, or they take the approach of giving you a mobile SDK. In both of those cases, they're kind of eliminating the direct to API attacks. So you're leaving a vector open for attackers to exploit. Now, most of them have come out with attempts to secure APIs. And the way that they're going to do that is when you hit an API, you are then redirected to a web page that assigns a cookie, and that cookie then acts as a mechanism by which they can enforce policy. This, is a bit of a cumbersome way to implement API security. It's going to impact the user experience. It's going to impact the development community significantly, because they're going to have to kind of code that into the applications. And it does not really address a direct to API an application that is using a direct to API call. So very different, very different approaches. You really do need to make sure that you analyze the approaches and which one is going to work most effectively for your environment. I see David has thrown another question that had come up, and I think both Alyssa and I can take this. I'll take the first stab. The question is, how are we different than an API gateway? So, if you were to go off and do some research on API gateways and API security, you're going to get a wide range of functionality in the offerings. An API gateway is primarily a management tool that allows you to manage the different APIs. AWS has is the most common API gateway out there, and it's used to manage all the different APIs for all the different services that Amazon has. And so it's a management and visibility tool. When you start talking about API security, most of the API security conversations revolve around vulnerabilities as opposed to automated attacks. So if you look at it from a WAF perspective, some of the WAF vendors are talking about API security. They're talking about it, but they're talking about it from a vulnerability exploit prevention functionality perspective, not so much from an automated security perspective. So we would not define ourselves as an API gateway. We can certainly provide you with visibility into your APIs as well as all of the different web and mobile applications, but it's not for the purposes necessarily of managing. It's for the purposes of securing those vectors against automated attacks that look to be legitimate. So that would be a long-winded definition of how we are different than an API gateway. Alyssa, did you have any additional comments about the API gateway and security question?
Yeah, I think I think you did a good job at explaining what an API management gateway does. What an API gateway does is, I would agree with you, it's definitely more on the administrative side of the house for APIs. But I think a more interesting question is, what's the difference between the different different security solutions to secure APIs? And one thing that I can say is things like web application firewalls, which is pretty prevalent for people to use for securing APIs, and why it's the wrong tool for the wrong job is, a lot of the other traditional security solutions designed to secure web applications instead of APIs are looking for things like SQL injection. They're looking for traditional web application attacks, whereas API security solutions are designed to take what could be a legitimate request, which looks like a legitimate request, which may not contain SQL injection, and actually make a determination that, oh, wait, this is bad. Or just because somebody has the key doesn't mean they're authorized to see this data. So I think there's definitely a distinction between API security solutions and web application security solutions, and they really are two different classes of products. And more importantly, even in the API security space, that's a pretty general term to describe an entire portfolio of different security solutions that address the API attack surface. So that would be the only 2 cents that I would add to that narrative.
Okay. Here's a question for you, Alyssa. What what could companies do to prevent code analysis in their mobile apps?
Yeah, so great question. So there's a new term being used called in-app security or in-app protection. And so this describes a category of products that will take web source code, web code, or mobile app code and obfuscate it and actually apply white box encryption to it and tamper detection, prevent nefarious people from reverse engineering it and finding, sensitive data in it. So they should be looking at in-app protection solutions to obfuscate their source code. Now, again, this isn't foolproof. Like any security solution, there's no silver bullet here. It is possible to take code that's been obfuscated and de-obfuscate it. It's just making it as hard as possible for hackers to do that and to be successful. Hackers are inherently lazy, Matt, as you know. And, what the objective isn't to fully prevent it. It's just make it as difficult and challenging as possible to where they move on to a softer target, move on to an easier target.
Yep. Cool. And one last question for you, Alyssa. What was the most startling finding in your research?
I would probably say the API case for third-party payment processors. So there were some apps that I looked at, some FIs that I looked at, where they ate their own dog food and they were good about not putting particular information in their app source code, but they hard-coded sensitive data for third parties in there, affecting the security of those third parties. So I think it was the most surprising finding, where I was expecting, if I'm looking at a bank's app, the most startling data, the most startling information would be related to that bank. There were some apps where that wasn't the case, and it was actually more compromising to the third parties that they were storing the data for in their app. So I would say that that's probably the most startling for me.
Remarkable. Well, I don't see any other questions coming in the question box. We'll wait just a second and see if folks are typing away. David, are you going to come back on and close us out here?
Yes, I do think that we've reached the end of the questions that came in. I want to thank you both for going ahead and addressing all of those, from the specific to the broad. I do think we're running close to our time limit here for our conversation today. So I want to thank both you, Matt, and Alyssa, for joining us, and again, giving us a really, really a great amount of material to think about going forward as it regards API security and bad bots in general. I want to let everyone know that the presentation will be available on the Finovate blog later on this month or early next, for those of you who'd like to go ahead and refresh and maybe revisit some of the concepts and items discussed here. Again, it was quite a bit of food for thought, so definitely take advantage of that opportunity. Keep an eye on the Finovate blog for more of that. So again, I want to thank our guests, Alyssa and Matt. I want to thank you for joining us, and we look forward to seeing you at our next Finovate webinar. Have a great day.
Thank you.
Thanks very much.